Good morning, good afternoon, good evening. It is the Oracle of Chinem Kutu and welcome back. Today we have got a very simple and compact, not simple but rather compact question. It was sent to me by a colleague as a challenge question, and the question is integrate from 1 to 2, 6x squared minus 8x all divided by 2x minus 1. So we have decided to, from time to time, upload the questions that we label as challenge questions. So this is our challenge question 1, and it's in integration. The integral sign, it's a sign that I really love. It's the S sign stretched out, summation. So the challenge questions basically are not very difficult questions per se. The difficultness lies in you realizing what method to apply to that question. The question as it appears there, it is very intimidating. You need to pinpoint exactly which method to apply in order for you to get the solution. So we are going to also post questions that we will label as teaser questions. And teaser questions are questions that have got a hidden fact in them. And if you do not realize that hidden fact, it might be a challenge for you to solve that question. So we will have teasers and we will have challenge questions. So today we will start with our first challenge question, and then somewhere along the line we will post a teaser. So here we are being asked to integrate this whole thing. And the first instance that I looked at the question, what came to my mind is the use of partial fractions. And there are actually several methods of applying partial fractions. So if you choose the wrong method, you might spend the whole day trying to solve this problem, and the solution might actually elude you. This question is good for students who are taking a calculus at the advanced level, the students who are doing mathematics, IGSCE advanced level maths, maybe also for students doing the same at the AS level. It would be too complicated for students who are taking additional maths at O level. But they also do integration, maybe probably not to this level, but definitely for students of calculus at the university level first year, you can get a question like that. So here is how I approached it. So what I did is I said let 6x squared minus 8x all over 2x minus 1 be equal to ax plus b plus c all over 2x minus 1. In other words, I'm trying to break down this whole complex presentation into subunits that we can then integrate individually without difficulty. So we say multiply throughout by 2x minus 1. So we will have 6x squared minus 8x equals 2. Obviously, we are going to say ax multiplied by 2x minus 1 and b multiplied by 2x minus 1 and c over 2x minus 1 times 2x minus 1, and the 2x minus 1 and 2x minus 1 will cancel out. So to simplify our work, we will just say brackets ax plus b brackets 2x minus 1 close brackets plus c. So then we can expand that and have the 2ax squared minus ax plus 2bx minus b plus c. And we can say 2ax squared plus brackets 2b minus a multiplied by x. So I just flipped the 2bx and minus ax so that I can have that expression. And here we can have the plus bracket c minus b. And I have also flipped the c and b so that we deal with the positive signs. They are easier to work with. So then to spice things up, we can say equate coefficients of similar powers or exponents. So then basically we have 6x squared and the coefficient of x squared is 6, and here we have 2ax squared and the coefficient of x squared is 2a. So in other words, we say 2a is equal to 6. And here we have got the coefficient of x as minus 8, and then here we have the coefficient of x as 2b minus a. So it will be 2b minus a is equal to minus 8, and the constant there is 0, and here we will also say c minus b, which is our common or constant factor, also equals to 0. So then we can say therefore 2a is equal to 6 and 2b minus a is equal to minus 8 and c minus b is equal to 0, and therefore c is equal to b. And here we have a equals to 3, and there we have 2b minus 3 equals to minus 8. So therefore 2b is equal to minus 8 plus 3, and 2b is equal to minus 5. Therefore b is equal to minus 5 over 2. So there, from here, we can conclude that c is also equal to minus 5 over 2. So then we write our integral in this form. So we say integral from 1 to 2 of 6x squared minus 8 over 2x minus 1 equals to integral from 1 to 2, all in closed brackets. We found out that our a is equal to 3, so 3 times x gives us 3x, and our b is minus 5 over 2, so here we have minus 5 over 2, and our c is minus 5 over 2 as well. So if we put minus 5 over 2 there, we will have minus 5 all over 2 brackets 2x minus 1 close bracket. We can put our 2 in the middle so that it looks neater. Our 5 in the middle so that it looks neater. So from there, we can then come here and say integral from 1 to 2 of 6x squared minus 8x all over 2x minus 1 is equal to, we write those integrals as individual. So here you can put your dx, and here you can also put your dx. Then we say that is equal to integral from 1 to 2 of 3x dx minus integral from 1 to 2 of 5 over 2 minus integral from 1 to 2 of 5 over 2 bracket. So here we can say dx minus that 2x minus 1 brackets dx, and we integrate this individually to get the solution that we are supposed to get. So we can then say this is equal to integral from 1 to 2 of 3x dx minus integral from 1 to 2 of 5 over 2 dx minus, let's take the 5 over 2 outside of the integral sign, 5 over 2 integral of 1 to 2 of 1 over 2x minus 1. We can put a dividing line here so we can follow exactly where we are. So then we integrate each part separately, and now we will use square brackets before we substitute the 1 and the 2 in order to get the values of our integrals. So here we say this is equal to the integration of x, basically you add 1 to the power of x, which becomes 2. You divide that 3 by the 2, so we have 3 over 2, and you write the x to the power of 2. We no longer need the dx, so we put a square bracket there, and our limits are 1 and 2. Minus, and here it's basically the integral of 1 if we had taken 5 over 2 outside the integral brackets. So we can just say square brackets 5 over 2 times x. The integral of unity is just the variable that you are looking for. And this, our limits 1 and 2. There we have minus 5 over 2 and the integration of this part is an interesting one. Basically, we use the reverse of the chain rule in differentiation. So this is the 1 over u, where our u is equal to. Yeah, so the integration of the third part is quite an interesting one. So we can write minus 5 over 2. And we realize that 1 over 2x minus 1 is actually the integral of limit x, which is the natural logarithm. So this is the chain rule of differentiation in reverse. So in other words, if we come here and we say dx of 1 over 2x minus 1 we say let u be equal to 2x minus 1, and therefore our y would be equal to 1 over u. So here basically we are saying, because we are saying it's the reverse of differentiation of the ln logarithm, the natural log, so this would be ln of 2x minus 1. So we say let u be equal to 2x minus 1, and then your y becomes ln of u. So then we say du dx equals to 2, and dy dx equals to 1 over u, and therefore dx of ln 2x minus 1 equals to, multiply this 2, if you multiply du dx by dy du, you will get 2 over 2x minus 1. So in essence, here we are saying dx of ln of 2x minus 1 equals to 2 over 2x minus 1. And then if this 2 comes this side, this is as good as dx of half ln of 2x minus 1 equals to 1 over 2x minus 1. Then if you integrate both sides, you end up with half ln of 2x minus 1 equals to the integral of 1 over 2x minus 1 dx. This is basically how you work out this integral here. So in other words, we realize that it's 1 over 2x minus 1, which means that it is actually a differential of the natural log. Then we said, okay, let us differentiate ln 2x minus 1, and we say let u equals to 2x minus 1. We are using now differentiation by substitution as a reverse of integration, and our y is therefore ln u, and du dx is equal to 2, and dy du is equal to 1 over u, and therefore d dx of 2x minus 1 is equal to 2 over 2x minus 1. And this 2 comes to the left hand side, it divides, and we have 1 over 2x minus 1 here, and therefore we have half ln of 2x minus 1 is our solution to the integral of 1 over 2x minus 1. So in other words, we come here and we say this is half of ln of 2x minus 1 square bracket limits 1 to 2. This is where the challenge comes from, to integrate this part of the question. So now once you are there, your question is almost done. We can now substitute 1 and 2 and subtract as follows. We say then this is equal to, still square bracket, first we substitute 2, 2 squared is 4 times 3, this gives us 12 over 2 minus, we substitute 1, 1 squared is 1 times 3 is 3 over 2, and our square brackets minus square brackets, we substitute 2, 2 times 5 is 10 over 2, minus we substitute 1, 1 times 5 is 5 over 2, and we take out this half outside, this becomes minus 5 over 4, and we start by substituting 2, this becomes 4 minus 1, that gives us 3, so it's ln of 3 minus, if we substitute 1, this becomes 2, 2 minus 1, this becomes minus ln of 1. Then we say this is equal to, and we solve what is inside the square brackets. So 12 over 2 minus 3 over 2 gives us 9 over 2 minus 10 over 2 minus 5 over 2 gives us 5 over 2 minus 5 over 4 times the solution there. And this is an interesting solution because we know ln of 3 minus ln of 1. Ln of 1 is actually 0 because we know that any number to the power of 0 gives you 1. And by definition, the definition of a log is basically the power that we need to raise the base in order to get the number 1 there. So if we are going to raise the natural number to the power of 0, we will get 1. And therefore, this is equal to 0, and we simply say this is ln of 3. And then here we have got 9 minus 5, that gives us 4, divided by 2, that becomes 2 minus 5 over 4 ln of 3. And that is the required value. So the solution here is done. The most interesting part of the challenge was to find this integral here. This part also was an interesting challenge to the question, and this part here now helped us get the integral of 1 over 2x minus 1, which is quite an interesting expedition. And now we are done. We have got a neat and nice value of the integral of 6x squared minus 8x over 2x minus 1. So please watch our videos, like them, and subscribe, share with your friends, discuss, and if you have got any comments, please don't hesitate to put them on YouTube. And if you have got similar challenge questions, please do send them to me through my WhatsApp platform, 0814411 or 814411 390. I thank you.